Why the computer? So, well, in this case, just what is the difference between any type of the data or any signal that you call digital? What does it mean? I always get that answer when I ask about digital. Okay, she said 1001. It's always. I always get that. Digital means 01, 01, 12, 01. Digital cannot have anything else, huh? Yeah, it's not continuous. That one thing. Actually, 0 and 1 is not continuous. Also, it has only two levels. Okay, 0 and 1. It doesn't have the level between 0 and 1. Okay, so that okay. Anything else? So I call that it's just the quantity. Okay, the quantity or the value is not continuous. It's discrete. Okay, and then what else? Who own the digital camera? Who have a digital camera? Who have a mobile phone that can send the picture? Well, you own the digital camera, right? Who? You? Okay. So which one that you have? How good is it? When you buy the digital camera, you just buy it because of the price, or you buy it because of what? When you try to shoot the digital camera, okay, what type of the parameter or what the parameter that you take a look of? Okay, pixel. What is a pixel? Resolution. What is the resolution? Huh? About what? Okay, you said you buy the digital camera. You take a look of how many pixels do they have. Okay, and then the answer is pixel will be resolution. And I said, what is the resolution? And you try to answer what is resolution. Huh? You just say it. It doesn't matter. Now go to color. Huh? So the resolution will be the resolution of pixel. Well, actually, okay, because the way that I think it's from the discrete, okay, or the continuous signal, okay. If we just only sample, okay, the data, okay, or we just sample some point out of this one, we will get the discrete sample point, okay. So in that case, you have something that we call the discrete time signal, okay. Okay, the very good example of this one, it will be, for example, if you try to measure your weight, for example, like every morning, that will be a sample. It's not the continuous, because you sample your weight, you weigh yourself every morning. You didn't weigh yourself every minute, every second. Okay, you weigh it every morning. So that will be the discrete. It's just a sample of the weight of yourself. Okay. So it will be the sample, the discrete weight. Okay, and then it's a discrete data. Okay. You know only how much you weigh every morning. each morning, okay, but you don't know during the day, okay, you don't know how much you weigh, or right after you eat something, okay. So that will be the discrete in time, okay, but the value, okay, is still, the value can still be the continuous value, because after you weigh it can be any value, okay, it can be 40, 41.25, it depends on the weight that you use, okay, the scale that you use, okay. So this one still discrete in time only. That's why we call the discrete time signal DT signal, okay. And this one will be how many pixels that we're talking about. So we're talking about how many points do we have, okay. Okay, so this is a sample point from the cosine signal that we have on the previous slide. Okay, now we sample it each point, okay, at the same duration or the same period. You can see that each point have a same duration. Okay, it's a interval of each point will be exactly the same. We call that one sample period. Okay, so if you take less sample, okay, this one won't represent the continuous signal, right? For example, you sample only that one and that one and that one. For example, you have only 4 sample points, okay, you will have a signal that look different, okay. So later on we will learn how many sample points do we need, okay, in order to be able to convert from the discrete time back to the continuous time signal, okay. And then I think it's the next one will be the digital signal. Now the digital signal will be, you tell me the digital camera, you look at the how many pixels and how many color they can represent, okay. How many color, it will be the discrete value, okay. So for the digital signal, now the value of sample point can have it within a set of discrete value. For example, if you use 8 bit, okay, you can have the value from 0 to 255. So you have totally 256 value. Okay, you cannot have value outside that length. Okay, so we call this one the digital signal. Okay, so now we have continuous signal, discrete signal, okay, discrete time signal and digital signal. Okay, the process that we do, okay, well, this is just representation of the signal notation. Okay, normally for the analog we will use the parenthesis like that, okay, but for this parenthesis, okay, we'll use it to represent the discrete time signal, okay, and then that one we use T, this one we use N, okay, this will be something that different between the analog or CT signal, and this will be the discrete time signal, okay. That small parenthesis, I don't know what to call that, bracket, okay. Even in Thai, I don't know what to call that also. How do you call this one in Thai? วงเล็บใหญ่ Really? Yeah, I don't know what to call it in Thai also. And then you call that one วงเล็บเล็ก วงเล็บเล็ก วงเล็บใหญ่ Oh, the other one is วงเล็บปีกกาเลย Yeah. I think it's that parenthesis and then that a bracket or something. Yeah, I don't know. I think that's something that I never call. Okay, but well, normally these two notation will be pretty much standard notation. When you see something is represented by T, okay, normally it will represent the CT signal or analog signal, and in the bracket, okay, it will be something that we call the discrete time or digital signal. Okay, when N, normally N is an integer, but for that